When we looked at linear systems of equations, we encountered cases where there were no solutions or inconsistent systems. That meant with linear systems that we had two parallel lines. We can also have cases with nonlinear systems where there's no solution. Since we're not dealing with straight lines, though, it's not a case of parallel lines. It's a case of simply the two graphs never intersecting with one another. In example 9, we have the equation x squared plus y squared equals 4 and y equals x squared minus 9. We'll start off with that second equation, which is the graph of y equals x squared, but shifted down 9 units. So our first point we could plot at 0, -9. At x equals 3, we would normally have a function value of 9, but that's being shifted down 9 units, so now that'll be at 0. So equation 2 is a parabola, or a graph that looks like x squared, shifted down 9 units. Equation 1 is the equation of a circle with a radius of 2. So we'll draw a circle with a radius of 2, and what we can see is that these two graphs never intersect with one another. That circle fits inside that parabola without ever intersecting with it. So for this case, there would be no solution since there's no point of intersection. That's one example of what this looks like graphically. If we were to approach solving this system algebraically, we could label these as 1 and 2. And in this case, look at updating equation 1 by multiplying both sides by 2 to get 4x squared plus 2y squared is equal to 10. Our second equation will remain unchanged, but we will go ahead and subtract 11 over to the other side. This will give us 5x squared is equal to -1, or x squared is equal to -1/5. But we know that that can't be true because x squared always has to be greater than or equal to 0. Regardless of what we plug in, we're always going to end up with a non-negative value. So what we would say is, in this case, that no real solutions exist. Unless we start taking into consideration complex numbers or imaginary numbers, which allow us to take the square root of negative values, there are no values for x that would make these equations true.